when 0.0129 moles of potassium iodide dissolved in 11.57 degrees Celsius water and made 40 grams of solution, the temperature of the solution decreased to 10.00 degrees Celsius. Assuming the container did not absorb or release any heat, what is the standard delta H of the following reaction? With the specific heat capacity of the solution being Cp equal to 4.184 joules per gram degree Celsius. The reaction, of course, we're looking at was dissociation of potassium iodide into potassium ion and iodide ion in aqueous condition. So, all right, you had a reaction happen in solution, which means we're looking at a calorimetry situation. And in calorimetry involving chemical reaction, we know where to start with. We always have delta H plus Q equal to 0. And the question now is, how many things, what are those, are involved in the Q process? Delta H, we know, is all about the reaction. Okay, so if you look at this, the only thing that could absorb or release heat in here is the solution. Container did not absorb or release any heat, so we don't even have to worry about the calorimetry. Now, with the solution, you have grams, you have Cp, so naturally you know your Q here will be calculated with Cp delta T. So plug everything that you have in there, so your delta H of the reaction plus 40 grams of solution times 4.184 joules per gram per degree Celsius times final temperature 10.00 minus 11.57 degrees Celsius would equal to 0. Notice that you will have a negative 1.57 degrees Celsius temperature change, which means that your solution is actually losing heat, which makes your reaction absorbing heat, and which makes your reaction a endothermic reaction, which has a positive sign for delta H. So calculation gave you your delta H here equals to a positive 263 joules. But what we need is not delta H. What we need is delta H standard. And the standard delta H, of course, would be for the number of moles indicated in the chemical equation, how much heat is involved. And we have 1 mole of Ki dissolved. You didn't dissolve 1 mole of Ki in the experiment. So the way that we get our delta H, standard delta H, would be you use your original delta H in the reaction, which is 263 joules, and this is happening over 0.0129 mole of Ki. And okay. And what you want is this happen to 1 mole of Ki. So mole of Ki would cancel, and you ended up with joules in your unit. Now, we look at the answer choices. Everybody has kilojoule unit, so whatever you get, you would turn them into kilojoules. So you get 2.04 times 10 to the 4th joule, positive sign, and that would translate into positive 20.4 kilojoules, and that would be the standard delta H value for the chemical reaction show. And that's the right answer.